Hello all, welcome back to my YouTube channel all about VLSI. In this video, we are going to discuss about TLM ports. This is a continuation video of part 1. So in this first we will once brush up what we have seen in our previous videos. So in our previous video about TLM ports, we have discussed we have started introduction of what do you mean by TLM ports, why we need TLM ports, why we are not using mailboxes. Yeah, and we have seen what do you mean by port and how to declare a port and how to initiate the communication and also we have seen what do you mean by implementation port and how it is going to look like and what is the syntax for declaring your implementation ports. These are all things we have seen in our previous session. Now in this session we will see one more type of port which is known as export. So basically an export simply forwards the method calls to connected input. So basically an export simply forwards method calls to a connected implementation port. So this export will act as a relay. So this is useful for hierarchical connections. Example, passing a port connection up to the parent component. Let's say suppose if we have a component like this and inside this we have one more subclass now, and inside this we have one more subclass. Let's say if this is having a port, and let's say we have another class like this, and here we have an implementation port. And let's say if I want to connect this port with this implementation port, then what I'm going to use is exports. So this will act as a relay. So this will act as a bypass. So this will connect our port to our implementation port. Okay, so this is how in the cases of hierarchical connections we are going to use this export. So basically these exports are going to use as a pass-throughs, and these are used when a component doesn't implement the interface but a subcomponent does. Okay, and this can be connected to both ports and implementation ports. You can connect an export to an port as well as you can connect an export to an implementation port. Basically in UVM, in the previous session also we have seen this. So in UVM provides a standardized way for components communicating by passing transactions. So we have seen two kind of communications. One is push based communication, where the data has been pushed from one initiator to the target. So let's say this is our initiator and let's say this is our target, and let's say target will have always implementation port and initiator will always have the port. Okay, so the initiator is going to push the data to the target. Okay, this is push based transaction. And in the second case, let's say this is our let's say this is our target and this is our initiator, but the data flow is same, but the target is having implementation port and initiator is having port, but the data direction is same. Here initiator is pulling the data. Okay, in this particular cases we will use get port, and in this cases we are going to use put port. Where the data is pushed, there we are going to use put. And in the second case, here the target is having implementation port and the initiator is having a port, and the data flow is from target to initiator. In this type of communication we are going to get the data. This is basically pull based communications. So this is the difference between your push based and pull based communication. So basically using this get port, when a component actively requests a data from another, and for example if a driver asking the sequencer or a FIFO for a transaction. So these are examples where we are going to use get ports. So already we have seen put ports. So same like this we are going to use this get ports. So this is initiating port that is going to call the get method. So previously we were using put method. Now we are going to use get methods. So typically used in components like drivers or monitors. And the key characteristics, which is basically this UVM get ports are declared in the components that request the data, and these are basically going to call the get method on a connected implementation port, and these are also type parameterized. All the TLM ports are type parameterized. So the syntax for your get port is same, UVM get underscore port. Previously we were using UVM put underscore port. Now we are going to use UVM get underscore port, and that parameter followed by get port, the port name, and followed by get implementation. Same as put implementation, you are going to use get implementation. The major difference between your put and get is the data flow. So where the data is being flowing, what is the flow of the data? So accordingly you are going to use. So if the data is flowing from the initiator to target, in those cases you are going to use push based ports, that is put port. Whereas if the data is flowing from the target to the initiator, there you are going to use pull based ports. ports. So these are the differences which you can follow. So when we were discussing, it may be a put port or it may be a get port. Let me take one push based ports. So let's say we have a port here, as well as here we have an implementation port. So here we are using a put port for transferring the data from initiator to the target. Let's say the data flow is from initiator to the target. Now in this particular case, here we are using a port and here we are using an implementation port. Now, and this is basically push based ports, that is we are basically using put method. Yesterday in our previous session we have seen this, and another is pull based ports where we are having an initiator here which is having a port and the data, and we have a target here which is having a implementation port, and the data direction is from target to initiator. Here we are going to use pull based ports, that is get port, where the data is being flowing from the target to the initiator. Here we are going to use get ports and here we are going to use put port. Now, so in basically in put port and get port, we need implementation ports to be executed. Till now, the examples which we have seen so far, in this examples, we use it or we have declared the implementation ports. The implementation port or the method, the implementation method should always be declared in the, so the implementation method should be present in the target. Now, so till now we have seen this particular ports. Now coming to another type of ports, which is nothing but UVM TLM FIFO. Basically UVM TLM FIFO is a transaction level type bounded or unbounded FIFO. It can be bounded or it can be unbounded, provided by UVM to simplify the communication between the components. So it's a built-in UVM component that provides put put and get and peek interfaces, and meaning it can be used to send or receive the data using both blocking and non-blocking. Okay, what do you mean by blocking and what do you mean by non-blocking, just we'll discuss. And till now whatever the methods which we have discussed, that is put methods and get methods, basically these are blocking methods. Okay, what do you mean by blocking and what do you mean by blocking, we'll discuss in our further sessions. Now, so in the case of previously, when we are using put ports and get ports, we need to implement this implementation ports. These implementations are mandatory. Okay. But in the case when we are using this TLM ports, we don't need to define our put underscore implementation port or get underscore implementation port. So the FIFO is going to have these implementations. So what is your duty? Just declare the ports with your component, and if you want you can use this FIFO, so you don't need to write down this implementation ports. You just use this FIFO. So if we are using this FIFO, we are not going to implement this implementation port, or we are not going to use this implementation ports. So let's see an example how we are going to use this implementation port and how we are going to connect them using our EDA playground. So before going to discuss the code, let us see one scenario where we are having an agent, and in this agent we are going to have a generator module. This is our block as well as our driver block we are going to have, and these are instantiated in our agent. Now, so if we are using a UVM TLM FIFO port, this is our UVM TLM FIFO port. It can be bounded or it can be unbounded. Now, what we are using now, let's say this generator is an initiator and this driver is also an initiator. So if we are using a FIFO, there is no need to use a implementation port. So the generator is also going to have the implementation port. So the generator is also going to have the port, and the driver is also going to have the port, and the FIFO, it is going to have the implementation ports. So using the put port, the generator, it is going to put the transactions into the FIFO, and using the get port, the driver, it is going to get the transaction from the FIFO. So using the put ports, the generator, it is going to put the transactions into the FIFO, and using the get ports, Using the get ports, the driver, it is going to get the transactions from the FIFO. So this is how, using this TLM FIFO without using any implementation ports, without declaring any implementation ports, we are going to put the data and we are going to get the data. So let us see how this is working. So let me declare the packages. Tick include UVM underscore macros.svh and import UVM underscore package. Now, here I am going to declare a class which is my generator, which is extending from my UVM component, and let me register it, UVM component utils generator. So within a function new, string name is equal to generator and UVM component parent and super dot new of name comma parent followed by end function. Now, so before this, let me create a packet class. So this packet I'm going to pass it from the generator to driver. So class packet, which is extending from UVM object. So let me register this first. UVM object underscore utils packet. So in this packet, let me create one data. So let's declare one data item. Int data is equal to, let's say, 10 end class. So before that, let me write the function also. Function new string name is equal to packet and super dot new of name followed by end function and end class. Now, so this is my packet class and this is my generator class. So in this generator class, let me create the instance of my packet. So packet pkt, this is the instance of my packet class. So within a build phase, so function void build underscore phase, I'm going to create the instance of my uh, packet super dot build underscore phase and packet is equal to packet type id create pkt comma this. So I've created the instance of my packet class followed by end function, and within a task run underscore phase, which is also expecting argument UVM underscore phase and phase. So what I'm basically doing is I'm going to use my port. So let me declare this as a rand variable so that I can randomize it. So I will randomize the data here in the generator. So what I will do is my transaction handle, that is packet dot randomize. So I have randomized it. Now using the put port, so let me declare the port also. In my generator, I am going to have one port. So the port name is UVM blocking put underscore port, and that type it is accepting is packet, followed by the port name is put underscore port. Okay. So using this, so in the new function, I will declare the instance of this. So put underscore port, which is equal to new of put underscore port comma this. So using this put port, I'm going to send the data put underscore port dot put of my transaction followed by end task and end class. So this is my generator class. So basically what I'm doing in my generator class is I'm first registering my generator class and I'm declaring a put port handle, blocking put port handle, and within a function new I'm creating the instance of this, and build phase I'm creating the instance of my packet, and I'm randomizing the packet in my run phase, and I'm putting the transaction into my port. Okay, so the transaction name is pkt. Now, so let me declare my driver class driver, which is extending from UVM driver. Let me register this. So let me copy paste, and here I'm going to declare the port handle UVM blocking get underscore port. Here also I'm going to use a port only, okay, of type packet, and it is get underscore port. So within a function new, let me copy this one, and the name of the class is driver. So I've created this, and within a build phase, let me copy from here. So let me create the handle for this packet. So packet pkt. So after that, in the run phase, what I'm doing is I'm going to get underscore port dot get of packet. So basically, I'm trying to get the packet, get underscore port dot get underscore packet. So that is what I'm doing. Simple. So in the driver, first I have created a driver class, and I have declared the port handle, and I register my driver. I've registered my driver, and I've declared the packet handle, and within a new function I'm creating the instance of my get underscore port, and within a build phase there is no need for this build phase, and within run phase I'm getting the packet. So let me create a display function in my packet class so that I can call that function. So function void display string s. So basically I'm going to display $display percentages, the value of data is percentage d, comma s, comma data. So I'm displaying this, so I will call this function. So first I will write in function, and in the driver class I'm going to call this function. So packet dot display. So I'm going to call this display function packet dot display. Now, so yeah, so this is my driver class, and let me create a test class test. So before that I should create an agent class, which is extending from UVM underscore agent. So here we are having an agent class, right? So we are going to declare an agent class, and in this agent class we are going to have my generator class handle. So first let me create the generator class handle. So generator, let's say genh, and driver drvh, and we are going to create the TLM FIFO handle, UVM TLM FIFO, and we should mention it is a typed class, so it is expecting a packet, and FIFO-H. Okay, now, so within a new function name is equal to agent UVM component parent super dot new of name, and I'm going to create the instance of my FIFO handle. So this is my agent class which I have written. Now in the connect phase, function void connect, which is expecting UVM phase. So it is connect underscore phase. Here what we are basically doing is we are going to connect my generator to FIFO's export. So this connection we should make first, this port and this export. So what we are doing, so we are basically doing generator port, generator handle is gen h. So first of all, within build phase, we should create the instances of this handle thread. So function void build phase UVM phase super dot build phase, and I should create my generator instance, and I should also create my driver instance. So I've created these two instances followed by end function now. So I'm going to connect my generator to my FIFO export. So generator dot put underscore port is my port which is available with my generator. So generator dot put underscore port. So this is the port which I'm going to use, put underscore port. So generator dot put underscore port dot connect, and I'm going to use my FIFO handle. So FIFO h. So here I'm going to write FIFO h dot my put underscore export. So this these TLM ports internally have exports. So I'm calling this export. So which is present. So I'm basically connecting this put port with my put export, and I'm going to connect my get port with my get export. So this is what I'm making. So I'm basically connecting put port with my put export, and driver drvh dot get underscore port dot connect of FIFO h dot get underscore export. So this is how I'm going to connect followed by end function and end the class. So this is what I'm going to make now in my test. So let me create a top model test which is extending from UVM test, and let me register the agent also. UVM. So I've registered my agent, and let me create my test. So let me create the handle for my agent, and before that let me register my test also. So within a function new, let me copy it from the top and paste it over here followed by end function. And what we are doing basically is yeah, so within a build phase function void build phase which is expecting UVM underscore phase super dot, and here we are going to create the instance of my agent type id create agent comma this. So I'm creating this agent followed by end function and end class. That's it. Okay, so next what we are going to do is within a top module I'm going to run my test. Yes. So this is what I'm doing. So let me save this and run this. So before that, I will call the display method. Yeah, I've called it. So we are getting driver. The value of data is 1. So this is what we are getting. So this is how we are going to use our TLM FIFO, and we are going to connect our components. So that's all about this video. So if you like this video, please like, share, subscribe to my YouTube channel all about VLSI. Thank you for watching this video.